Hello, my dear students, and welcome back. I know your exams are just around the corner, so today we are going to tackle one of the most important scoring chapters, production and costs. Chalo, let's make sure you get full marks in this.
Now, I get it. This chapter, with all its curves and tables, can seem a little scary. I hear it all the time from students. Sir, this is just so confusing. But you know what? Trust me, it's not.
And I'm going to prove it to you. We are going to master this entire chapter in just a few minutes. Pakka promise. And to make it super easy, we'll follow the story of our good friend Raju and his dream to open a samosa stall. Okay? Let's dive in.
So first up, let's meet Raju. He's a bright young man with a really delicious dream. Let's see how his big idea helps us understand the absolute basics of production. So Raju wants to open a samosa stall. What even is production? Well, it's just taking inputs, things like flour, potatoes, oil, and of course a cook's hard work, and turning them into an output. And in Raju's case, the output is yummy, hot samosas. Simple, right? Every business has a kind of secret recipe. In economics, we call this the production function. Think of it like a formula that tells Raju the absolute maximum number of samosas he can possibly make with the stuff he has. It's all about being efficient and not wasting anything.
Okay, so Raju's inputs are of two types. First, you have the pakka stuff, or what we call fixed inputs. A perfect example is the rent for his stall. I mean, whether he makes 10 samosas or 1,000, the rent stays the same, doesn't it? It's fixed. Then you have the kacha stuff, or variable inputs. These are things like the potatoes, the oil, and the number of cooks he hires. The more samosas he wants to make, the more of these things he's going to need. They change. So, Raju's stall is all set up. Now, he needs to hire some cooks. Let's find out what happens to his samosa making when he starts adding more and more people to his tiny little stall. This is where it gets really, really interesting. All right, have a look at this table. Total product is just the total number of samosas they make. Average product is the number of samosas per cook. But marginal product, now that's the key. That's the number of extra samosas the newest cook adds to the team. Just notice how that number first goes up, from 10 to 16, but then it starts coming down. And if we plot that total product on a graph, it looks something like this. See, as Raju hires more cooks, the total number of samosas goes up and up. At first, it rises really fast, but then it starts to kind of flatten out. So why does that happen? The answer, beta, is right here in this graph. This is the real star of the show. Look at the marginal product curve, the MP curve. See that upside-down U-shape? At first, each new cook he hires adds a lot of extra samosas. But after the third cook, the stall gets way too crowded. They start bumping into each other, getting in each other's way, and the next cook actually adds fewer samosas than the one before. And that, my friends, is a perfect illustration of the law of diminishing marginal product. I'm sure you've heard your mummy say, "Too many cooks spoil the broth." It's exactly that. After a certain point, adding more of one thing, like cooks, while keeping everything else fixed, like the stall size, leads to less and less extra output. Okay, the samosas are selling like hotcakes. But now Raju has to pay his bills, his kharcha. So let's switch gears and talk about costs. Remember our pakka and kecha inputs? Well, their costs behave in the exact same way. The total fixed cost, that's Raju's rent, is just a flat line because it never changes. But the total variable cost, for all the ingredients and wages, it just keeps going up with every single samosa he makes. His total bill, or total cost, is simply these two added up. Now just think about the rent per samosa. If Raju sells only one samosa, that one poor samosa has to cover the entire rent. But if he sells 1,000 samosas, that rent gets spread out, and the fixed cost for each samosa becomes very, very small. And that is why the average fixed cost curve is always falling. All right, get ready. This is the part that I promise you comes in every single exam. But please don't worry at all. I call these the Smiley curves because they're U-shaped. And after this, you'll be smiling too because you'll realize just how easy they are. So first, let's look at the average variable cost per samosa. In the beginning, when the first few cooks are working together super efficiently, the cost per samosa actually falls. But remember our law of diminishing marginal product? When the stall gets too crowded, the cooks become less efficient and the cost per samosa starts to rise again. And that's exactly why it has that U shape. Now, here comes the hero of our story,
the marginal cost. This is simply the cost of making just one more extra samosa. It also falls and then rises pretty sharply, kind of like a Nike swoosh. And here is the most crucial point. You have to remember this. It always cuts the AVC curve at its absolute lowest point.
And lastly, we have the big brother, the short-run average cost curve. This is the total cost per samosa, both fixed and variable combined. It's also U-shaped for the very same reasons. And just like its little brother, it is also cut by our hero, the marginal cost curve, right at its lowest point.
See? Not so hard, was it? Now, to make sure you get full marks, let's practice a real board exam question. Chalo, let's solve this together. This is such a classic 3-mark question. They just want you to explain the relationship between that big brother SAT curve and the Nike swoosh SMC curve. So how do you write the perfect answer?
Listen, it's as simple as 1, 2, 3. First, you just write this. When the cost of the next samosa, the SMC, is less than the average, the SAC, it's going to pull the average down, so SAC falls. Second point, when the cost of the next samosa, SMC, is more than the average, it's going to pull the average up, so SAC rises. And third, the golden rule. When SMC equals SAC, the average is at its absolute lowest point. This is where that SMC curve cuts the SAC curve from below. You just write these 3 points, draw the diagram, and I guarantee you'll get full marks.
And that's it. Production and costs all done. See? It's all about simple logic and just telling a story. You are all brilliant, and you are going to do wonderfully in your exams. You have totally got this. All the very best.